Hello everyone and welcome back again to image processing using Python. So in this session we will be going through how an image can be blurred and how it can be sharpened. So these two set of operations we'll be looking at using our example program. So going to programming and Genie. Okay, we have got here code. So in this program, blurring and sharpening images. What is blurring? Blurring is we are going to change the borders of objects, and we will change the intensity of pixels of objects. Okay, so suppose blurring, if we want to blur any image, so we will be changing the intensity of the pixels. So first we have to identify the intensity, the rapid changes in intensity that will define borders, that will be helpful in identifying borders of objects. So once we are able to detect those pixels which have rapid changes in intensity, then we will be performing operations on those particular pixels. So with that we'll just get started. Import CV2, we have to import computer vision library compulsorily, and we have to import numpy as an NP, a numerical Python, and we are denoting it as NP. And then we are reading an input image. Here we are reading image 4.jpg, that is the input image file name, and using function imread, it is a built-in function defined in CV2, and this we are storing in image variable. We can write any name here, give any name here, it's only variable. And then we are displaying that original image here using imshow built-in function defined in CV2. After that we want the user to press key so that we proceed further. So now here to blur an image we are using .cv2.blur function. So what does it do? It does, it has some internal operation. What those internal operation is, it is performing averaging operation on an image, or we can say it is performing convolution on two objects, on two inputs, so that it produces the blurred image. So let's see what are those two inputs. So we are using here a normalized box filter as an input to the image. So we can vary and give any size. With that, depending on that size, the amount of blurriness is observed in the image. So suppose, what is that box filter? So a 3 by 3 box filter of size will have 3 arrays and 3 columns. Okay, and if we are assigning all values to all these array values, then we call it 1 by 9 box filter. Size is 3 by 3. So this type of filter we are assigning it as an input argument to the .blur function. So we are first assigning it to a variable, say k size, and presently we are using 9 by 9 blurring factor, and then we are giving image variable as the input image as a input argument, and this we are storing it in blur. Now this is what internally it is performing some mathematical operations. So after this we want to show the blurred image to the user, and we will wait for the user to enter any key, and then we are proceeding it further, and then we are going to perform sharpening of an image. So let's see what is sharpening. Sharpening is we are highlighting edges in an image, edges of objects, different objects. So to identify any object in an image, we are identify first the rapid changes in intensity here. So first when we are able to identify such pixels, then we will highlight those pixels much in one color, and we will give another color to the rest of the pixels. So this will highlight only the borders of an image. Alright, so for that we are defining one array in a specific format defined in numerical Python package. So we are defining with some values, say np.array So this is the particular values. Any changes in these values will disturb or will have a direct impact on the borders what and on the image, on the resulting image. So we have to choose these values very precisely and very wisely, and then we will have to normalize it to 1, because that these ones will be having brightness, will have impact on brightness of the resulting image. So now here for sharpening images we are using a built-in function called cv2.filter2d. so this is a built-in function defined in cv2, and syntax is cv2.filter2d. it has got 3 input arguments: image, input image, d-depth and kernel. When we say d-depth is equal to -1, we mean that the sharpened image will have the same depth as the original image. The resulting image will have the same depth as original image, and the kernel is what the array we have already assigned here. So these values we have selected here. So let's see the results and observe, and we'll have an idea to know what these values will have impact. Okay, so after this we'll be using ImShow function to display the sharpened image, and then we are waiting from the user to press any key to proceed further, after which we'll be destroying and collapsing all windows with function destroy all windows defined in cv2. Okay, let's go ahead, go to build and say execute, and let's see the results. Okay, this is what the original image is. It's a beautiful scenery. Just have a look and keep an eye on objects. So let's see, I'm pressing a key here from keyboard. So we have got a blurred format of the original image. Okay, so we can observe the blurriness. We can change the blurriness by changing this kernel size, this filter size. Okay, let's see another result. Okay, I'm going to press one more key. This is the sharpened image. Okay, it is going to highlight the edges, and it is going to highlight the already highlighted colors. I already highlighted objects, so it's here it has highlighted the less highlighted spaces in the image. So you can observe here the whiteness in water, and here it is just going to increase the whiteness in water, and even you can change this using kernel filter. When you change these values, we'll see the difference. Okay, let's first change this case size to observe the blurriness. I'm reducing it to 5 by 5. Save it. Exit the program first. Okay, now go to build and execute. So this is what the original image is. Now you can see the blurriness is reduced typically, because we have reduced our convoluting factor, that is case size. Okay, okay, so enough for this. You can give a try, and you can play with the functions to get your own desired level of blurriness and sharpness. Hope you understand this. We have got a good packages, OpenCV and NumPy, which are very much useful in performing particular operations on images. So hope this is enough to get started, and we'll see you in next tutorials.